All right, guys, we're finishing our two-part series on L'Hopital's rule, and in this video, we're going to look at some of the trickier indeterminate forms, the exponential ones, as well as infinity minus infinity. So here are the three forms we're going to look at. The first one is 1 to the power of infinity. You see it like this. Infinity to the power of 0, so like this. And in 0 to the 0 power, you might see it like this. The strategy for these is the strategy for these is the same. You let y equal whatever the function is, then take the natural log and solve the new limit, and then you exponentiate at the end. I'll run through a couple examples. In this case, if we take the limit as x approaches 0, this is going to approach 1 to the infinity power. You would not write equals 1 to the infinity, so this is an exponential form of 1 to the infinity. So the first thing we do is let y equal the function, and then you take the natural log of both sides. The reason we take the natural log of both sides is because part of the problem with this problem is the exponent is part of the indeterminate form. When we take the natural log, we can rewrite the exponent using the power property. And this would equal natural log of 1 plus x over x. Now, if we take the limit as x approaches 0 here, the numerator approaches 0 and the denominator approaches 0. So our new form is 0 over 0. So we could do L'Hopital's rule. So this would equal the limit as x approaches 0 of the derivative of the denominator, 1, the derivative of the numerator, 1 over 1 plus x. Now if I take the limit as x approaches 0, this equals 1. But remember, this is natural log of y equals 1. We have to exponentiate both sides. Y equals e to the first power, or just e, and that is our limit. Here's our next example. If we let x approach infinity, this would approach infinity to the 0 power, which is the form infinity to the 0. Now we let y equal the function, take the natural log of both sides, and apply the power property. Now the numerator as x approaches infinity is infinity, and so is the denominator. So the new form is infinity over infinity. So we're going to apply L'Hopital's rule. So this is the limit as x approaches infinity of 1 over x over, and that limit is equal to 0. But we don't stop there. Remember, natural log of y is what is equal to 0, so you have to exponentiate our answer, and so the limit is equal to 1. So our final answer is 1. Okay, so for this one, as x approaches 0 from the right, both the exponent and the base approach 0, so this would be 0 to the 0 power, and that's our form here. Same thing, you let y equal the function, natural log both sides, and then use the power property to rewrite this as x natural log x. Now, if you let x approach 0, you would have 0 times negative infinity, which is an indeterminate form that's a product, and we already know how to handle these. You multiply by the reciprocal. So we would rewrite this as natural log x over 1 over x. Now, if we let x approach 0, the numerator approaches negative infinity, and the denominator approaches infinity, so our new form is infinity over infinity. It doesn't matter if it's positive or negative infinity. So we take the limit as x approaches 0 from the right, and we apply L'Hopital's rule. The derivative of the numerator is 1 over x, the denominator negative 1 over x squared. Simplify that, you would have just negative x, and that limit is equal to 0. Now, again, we have to exponentiate our final answer because we natural logged the original problem. So e to the 0 is just 1. That is our final answer. Now we want to look at indeterminate forms involving a difference. Our strategy is going to be rewrite it as a fraction. Then you simplify, then you evaluate the limit. Let's take a look at some examples. So here, if we let x approach infinity, we would have the form infinity minus infinity. And in this case, what we're going to do is multiply by the conjugate. Remember, the conjugate is changing the sign between the two terms, so it'd be plus x. But since I multiplied by the conjugate, I have to also divide by the conjugate, like that. And the strategy here is that when you multiply by the conjugate in the numerator, when you FOIL those out, you get the first term squared, which is just x squared plus x, minus the last term squared, minus x squared, all over. Notice the x squareds are going to cancel here, and we would have the limit as x approaches infinity of x over square root x squared plus x plus x. Now, one of the things you can do here is divide every single term by x. You would divide x by x, divide this x by x, and divide this entire square root by x. When you divide in a square root by x, that's the same as dividing by the square root of x squared. This would simplify to 1 over square root 1 plus 1 over x plus 1. Now, if I let x approach infinity, just this term goes to 0, and I would have 1 over square root of 1 plus 1, which is 1/2. Now, I didn't actually apply L'Hopital's rule in this case, but our final answer is 1/2, and that's how you handle one of the forms that results in a difference for the indeterminate form. Now, in this example, we're going to let x approach 1 from the right. If we do that, the denominator here, natural log, is going to approach 0, but from the positive side, which is in the denominator. So this whole fraction is going to approach infinity. And as x approaches 1 from the right here, the denominator approaches 0, but from the positive values only. So this is also infinity. And then we have the form infinity minus infinity. The strategy for this one, we want to get it as a fraction. We don't want to multiply by the conjugate, but since we have two fractions being subtracted, we can use a common denominator. So our common denominator in this case would be x minus 1 times natural log x. And then if we cross multiply, you would have x minus 1 minus natural log x. Now, if I let x approach 1 from the right, the numerator here, the x minus 1 is going to be 0, minus natural log of x approaching 1 is going to be 0 also. And the denominator is also going to approach 0. So our new form is 0 over 0. So we have the limit as x approaches 1 from the right, and we're going to differentiate numerator and denominator. So the x minus 1, that derivative is 1. The natural log x, that derivative is 1 over x. In the denominator, we'd have to use the product rule, natural log of x plus x minus 1 times the derivative of natural log x, which is x over 1. Let's clean this up a little bit. Limit as x approaches 1 from the right. You have natural log x plus 1 minus 1 over x. I just divided the x minus 1 by the x. Now, if we take the limit as x approaches 1 from the right for this, you would have 0, and the denominator here would also approach 0. So we would have to apply L'Hopital's rule again, and the numerator would just simplify to 1 over x squared, and the denominator would be 1 over x plus 1 over x squared. Now, if you take the limit as x approaches 1 from the right, the numerator is 1, denominator is 2, so that's 1/2. Now, be careful here. You don't have to exponentiate here. I know the first couple examples we did because we had to take the natural log, but this strategy is different, so we don't have to exponentiate our final answer. Our final answer is just 1/2. All right, so in summary, exponential forms, you want to set the function equal to y, take the natural log, then apply L'Hopital's rule as necessary, then exponentiate your final answer. When you have a difference, you want to combine them into one fraction and apply L'Hopital's rule from that point as necessary. Well, that's it for L'Hopital's rule. Hope that was helpful to you. If it was, give this video a like as well as subscribe to the channel, as I'll be releasing more content. Take care.